which direction does it travel? The opposite direction. So do you see that DNA polymerase III is going to have to get inside there and build them in sections at a time? So DNA polymerase III built this section, and then once some more DNA was unzipped, it built this section. Do you see why there's a 1 and a 2? And then it built this section right here. And then after more of it got unzipped, it built this section right here. See that 1, 2, 3, 4? Does that make sense now? And then as DNA is getting unzipped, it's going to build another section right here. Doesn't that make sense? Okay? So DNA polymerase on this track lays down one continuous section of nucleotides. DNA polymerase on this section, however, has to do it in fragments. And does anyone have an idea of the names of those fragments? I know somebody in this room does. Nobody does? Who was your biology instructor? You said you know the name? I'll get to those words in a minute, but there's a name specifically for the fragments. Who said that? You did? Okazaki fragments, named after the scientist that discovered these fragments. Another test question. How many Okazaki fragments do you see in this diagram? Let's see, 1, 2, 3, 4. The fifth one hasn't been, oh, there's a beginning of the fifth one right there, right? Those fragments have to be cemented together. Do you know the name of the enzyme that does that? DNA ligase. Does DNA ligase have to work on this strand at all? No. There are no fragments. Why? Because DNA polymerase III travels in a 5' to 3' direction and can continue in a continuous movement as this unzips. Which segment do you think gets made faster? This segment or this whole segment? The top segment. This is much more efficient. This one takes longer. Now do you understand why we have the words leading strand and lagging strand? Do those words make sense now? Cool? Good so far?